All right, we're going to continue our discussion on solving rational inequalities. This is lesson number 3 on this topic. And so we're going to look at 3 problems. Now the inequalities, the rational inequalities we're going to look at will be of this form. So it'll be some polynomial divided by another polynomial. And then it'll be some inequality and you'll have 0 on the other side. So it'll be a rational expression, either less than equal to, greater than or equal to 0. All right, now as you go through the process, just as in the previous 2 lessons, we're going to use this algebraic approach. So we're going to go over that as we go through these problems. So again, this is the 3rd lesson on this topic. So let's look at the first example. So in the first example, we have x plus 4 divided by x squared minus 9 is greater than or equal to 0. So we have this rational inequality. Now when solving a rational inequality, you do want 0 on the other side. And so in all our problems, even in the previous 2 lessons, you saw that you did have 0 in each case. Okay, so as you go through the process, remember the first thing you want to do is to factor both numerator and denominator if possible. So in this particular case, I'm going to rewrite this because I can factor the denominator. I'm going to go ahead and rewrite this as x plus 4 divided by x minus 3 times x plus 3 is greater than or equal to 0. Okay? So I factored the denominator. The numerator you can't factor any further. Okay, so remember the whole process, and you want to solve this rational inequality. You're looking for values of x for any real number for x that will make this rational expression greater than 0 or equal to 0. So whatever value of x works, that value of x, that solution, should make this rational expression positive, because greater than 0 means positive. So you want this to be positive or equal to 0. Okay? All right, now the first thing you're going to do, as we did in the previous 2 lessons, was you have to find out what makes this rational expression 0. So you want to find the zeros. And we saw in the previous 2 lessons that this rational expression is 0 whenever the numerator is 0. So all you do is set that numerator equal to 0. So notice that when I set that numerator equal to 0, we end up with a linear equation, and so x plus 4 is equal to 0 when x equals negative 4. So this is your 0. All right. Then we also know this. We also know that a rational expression may be undefined. And it's undefined when the denominator is 0. So now we have to find, in part 3, we have to find what makes the denominator 0. And those are going to be called the undefined points. So now we're going to find the undefined points. And to find the undefined points, you're going to set the denominator equal to 0. And I always tend to use the factor part. So we have x minus 3, x plus 3 is equal to 0, and we set each factor equal to 0. And when I do that, x minus 3 is equal to 0 when x is equal to 3, and x plus 3 is equal to 0 when x is equal to negative 3. So these are your undefined points. Okay? Now once you find your zeros and once you find your undefined points, you're going to put these on the number line, and you're going to remember it's going to divide the number line into intervals. And then we're going to pick test points in each interval to see which one is a solution to this inequality. All right, so let's go ahead and put those on the number line. And we have 3 numbers we have to put on the number line. 1, 0, and 2 undefined points. Make sure you put them correctly. So negative 4 is going to be listed first. Then we have negative 3, and then we have positive 3. So those 3 numbers divide the number line into 4 intervals, just as we discussed previously. So we're going to have to pick test points in those intervals because I want to determine which of those intervals from negative infinity to negative 4 and then the other interval is from -4 to -3, -3 to 3, and then 3 to infinity, will be solutions to this inequality statement. All right, so the test points, let's go ahead and choose a test point -6 here. Now, it's always nice to use integers, but sometimes you cannot. So we're going to have to use a decimal. There is no integer between -4 and -3, so let's choose -3.5. And then from -3 to 3, we're going to use 0. 0 is always a nice one to use. And then from 3 to infinity, let's use 5. Okay. I always tend to go back to the factored part. You can go back to the original problem, just got to be careful because here you're squaring x. So when you square a negative number, you better make sure you end up with a positive number. So that's why it's always nicer to go back and use the factored part. Do notice that in this rational expression, there are 3 factors. You have 1 in the numerator, and you have 2 in the denominator. Okay? So the factors in the numerator is x plus 4, and the 2 factors in the denominator, one's x minus 3, and the other one's x plus 3. Okay, so we're going to go ahead and substitute the test point, -6, into the rational expression. So we have -6 plus 4 divided by -6 minus 3 times -6 plus 3. And I'm going to go ahead and put that work down here because I don't have enough room here. -6 plus 4, that's a -2, so the numerator is negative. And then in the denominator, your 2 factors, the first one, -6 and a -3 is a -9, so that's negative. And then -6 plus 3 is a -3, so that's negative. And then we have a negative in the numerator. The denominator, a negative times a negative is a positive, and then a negative divided by a positive is a negative. So what that means is that in this interval from -infinity to -4 up to -4, any real number that's in that interval will make this rational expression a negative number. But I want this rational expression to be positive, greater than 0. So this interval is not going to be a solution. So my solutions will not be from -infinity to -4. Let's go to the next interval. -3.5 is my test point. So we're going to substitute just like we did with this one. We're going to substitute, in this case, -3.5. So I have -3.5 plus 4 divided by -3.5 minus 3 times -3.5 plus 3. -3.5 plus 4, that's a positive number. So that's positive 0.5. -3.5 and a -3, that's a negative number. And then -3.5 plus 3 is also negative. And so the numerator is positive. The denominator, a negative times a negative is a positive. And so we have a positive divided by a positive, which is a positive. So that interval, no matter what real number I choose in this interval, it's going to make this rational expression, or this one, a positive number. So that means, see, I wanted positive, so that means that all real numbers in this interval is a solution. So I'm going to check that off. Let's go to the next test point, 0. So I have 0 plus 4 divided by 0 minus 3 times 0 plus 3. 0 plus 4 is positive. 0 minus 3, that's a negative number. That's a -3. 0 plus 3 is a positive 3. So we have a positive divided by a negative times a positive is a negative, and a positive divided by negative is a negative. So that's negative. So what that means is that any real number between -3 and 3 in that interval right here will make this rational expression, or this one, they're both the same, a negative number, but I want positive, so that's not going to be a solution. So I'll put a little X there to remind me not to use that interval. And then the last interval is, the test point here is 5, so do the same thing. 5 plus 4 divided by 5 minus 3, 5 plus 3. So the numerator, 5 plus 4 is positive, that's a positive 9. 5 minus 3 is positive 2, so that's positive, put positive here. And then 5 plus 3 is 8, and that's positive. So we have a positive divided by, and a positive times a positive is a positive number, and a positive number divided by a positive number is still a positive number. So it has to be positive. So any real number in this interval from 3 to infinity, or greater than 3 I should say, is going to make this rational expression a positive number, and that's something I want. Okay, now we got to talk about whether we need open circles or closed circles at these zeros and undefined points. Remember, and we talked about this in the previous two lessons, the undefined points will always have open intervals or open circles, and the reason is because it makes this rational expression undefined. So it cannot be a solution because you cannot divide by 0. So right away, for the undefined points, you're always going to put parentheses. So 3 and negative 3, parentheses, or I'm sorry, open circle. When we do the interval, it's going to be parentheses. At negative 4, so the 0 will either be open circle or closed circle depending on if you have an equal sign. So since that's an equal sign, then that is going to be a solution. That 0 will be a solution. So I'll put a closed circle there. And so therefore we can indicate the answer. So we have this interval and this interval right here. So 2 intervals. So my solution, you're going to say bracket, make sure it looks like a bracket, bracket negative 4, all the way to negative 3 with a parentheses, union, and then parentheses 3 all the way to infinity. Okay? And remember the infinity, negative infinity, if that was a negative infinity on this side, you're always going to put parentheses. And so any real number in those 2 intervals will be a solution to the original inequality. And that's it. So that's number 1. Very simple, not difficult at all. Okay, let's look at the second one. In number 2, we have this example. We have 2 divided by x plus 5 is less than 0. 2 divided by x plus 5 is less than 0. So as before, we got to factor both numerator and denominator. You'll notice that the numerator is a constant, so there's no variable expression there. So I'm going to leave that as that constant. X plus 5, there's not much I can do with that. That's a linear factor, so I'm going to leave it as that. So notice number 1, there's you didn't do anything with, just like in comparison to what you did here. In that first step in number 1 here, you could factor this quadratic expression because that was the difference of 2 squares. So what you're going to do here is now go to steps 2 and 3. Okay, now got to be careful here. In all the problems we've done in the past, there's always been a variable in both numerator and the denominator. Now you'll notice here, there's no variable. So don't let that throw you off. Think about what you're finding. So to find the zeros, remember to find the zeros, you set the numerator equal to 0, right? Well, the numerator is 2. I set it equal to 0, but remember there's no variable here. So you can ask yourself, does this make any sense? Is 2 equal to 0? And the answer is it's not a true statement, right? That doesn't make any sense. So what that means is that there is no zeros. There is no zeros. All right? So in the previous problem, you had a 0, negative 4. Here, there isn't any. There's none. There's no variable here, so there's no number that's going to make this expression equal to 0. Okay? Now, we do have undefined point. So now we got to find the undefined point. And we do have an undefined point because this linear expression, when I set equal to 0, there is a value of x that will make that equal to 0. So if I subtract 5 from both sides, I get x to be negative 5. So there is your undefined point. All right? And so in the previous problem, you had 3 numbers to put on the number line, right? Here, you only have 1. So, but the reason why some students would find this one a little bit more difficult than this one is because of this number. There's no variable in the numerator, so sometimes it throws you off. So you got to be careful. You got to think about what it is you're saying. So to find the zeros, you said the numerator equals 0, but in this case, it doesn't make any sense. So there isn't going to be any zeros. All right, so all we do is just put that one number on that number line, right? And since that's an undefined point, we're going to automatically put a 0. An open circle there, I meant an open circle. Okay, so now we're going to pick test points. So so notice that this undefined point divides the number line into two intervals. So we got to figure out which one of those intervals is a solution to this inequality. And I want this rational expression to be less than 0, so meaning I want this to be a negative number. So I'm going to pick a test point on either side. So I'm going to use -6 and 0. So let's do -6 now. So I get 2 divided by -6 plus 5, right? 2 is a positive number, so the numerator is positive. Y'all agree? 2 is positive, right? So that's positive. The denominator, -6 plus 5 is a -1, so that's negative. A positive divided by a negative is a negative. So that interval, no matter what real number I use in that interval, it's going to make this expression negative. So that means that this interval is a solution. Now we go to this one, 0. Do the same thing. 2 is positive, so I get 2 divided by 0 plus 5. 2 is positive, so that's positive, divided by 0 plus 5 is positive. A positive divided by a positive is a positive. So any real number greater than -5 is going to make this inequality, this rational expression, I should say, this rational expression a positive number, but that's not going to be a solution because I need it to be negative. So I put an X there. So your solution, there's only one interval. Your solution is from -infinity all the way to -5, parentheses. And that's all you do. So any real number in that interval is a solution to this inequality. All right? And then finally, let's do one more. So this is going to be number 3 rather, sorry. You have -x minus 2 divided by 2x plus 5 is less than or equal to 0. So -x minus 2 divided by 2x plus 5 is less than or equal to 0. In both of those cases, those are linear factors, so I'm just going to go ahead and leave them as such. And I'm going to go directly to steps 2 and 3. So in step 2, let's go ahead and find the zeros. I do have a variable in the numerator. So let's see what the zeros are. So I have -x minus 2 equals 0. Solving for x, I get adding 2 to both sides. I get -x equals a positive 2. To get x by itself, see that's -1x. I'm going to have to divide by -1. And a -x divided by -1 is a positive x, equal 2 divided by -1 is a -2. So there's your 0. Okay? Your undefined point, that's where this rational expression is undefined. So that's in a rational expression undefined when the denominator is 0, because you can never divide by 0. So we're going to set that equal to 0, just like this. So I'm going to solve this linear equation, subtract 5 from both sides. I get 2x equals -5, divide both sides by 2, and my undefined point is -5 halves, or as a mixed number, that's -2.5. Okay? So there's your undefined point right there. That's an arrow. Undefined point. Okay, now I'm going to put this on the number line, and we're almost done. So I have two numbers to put on this number line, -2 and -2.5. All right, so here's -2.5, -2.5, and then -2. All right, so now we've got to pick test points. So use integers whenever possible. It makes things easier on yourself. So let's say, let's go ahead in this one and use -3. All right, now be careful here. -2.5, -2. There is no integer between those two. So I'm going to use a decimal that's in there, and let's use a decimal that's to the tenths place. Makes things a lot easier the fewer digits you use. So let's say -2.3. Do y'all agree that -2.3 is between here, right? You could say -2.2, -2.1, -2.4. It's always easiest to use the fewest number of digits. And then from a number greater than -2, let's say 0. And now we're going to just substitute those numbers into this expression. All right, now you got to be careful because there's the number in front of x is negative. That's a -1, and here that's a 2. So you got to be careful. You may need to use your calculator if you have to. So let's start with -3. Now I'm going to go ahead and write this out to be a little bit more careful. This says the opposite of x. So the opposite of, and then my test point's -3. So what that looks like, the opposite of my test point, the opposite of x. -2 divided by 2 times -3 plus 5. Now see that? Okay. Now be careful. The opposite of a -3, I'm going to put that down here so you can see this. The opposite of a -3 is a +3. So that becomes 3 minus 2 divided by 2 times -3 is a -6 plus 5. And now 3 minus 2 is a positive number. That's +1. I'm going to go ahead and put +1 just to show you. So that's +1. The denominator, -6 plus 5 is a -1. And a 1 divided by -1 is a negative number. So no matter what real number I use from -infinity up to -2.5, I'm going to end up making this rational expression negative. And notice that the solutions to this rational expression, whatever value of x works, better make this rational expression less than 0, meaning negative, or 0. And so since any real number in this interval does make this negative, then that's going to be a solution. Check that off. Then we go to -2.3. We're going to do the same thing, so be careful. So think of this as the opposite of x. So the opposite of -2.3 minus 2 divided by 2 times -2.3 plus 5. Okay, so I'm going to write that information down here. The opposite of a -2.3 is a +2.3 minus 2 divided by 2 times a -2.3 is a -4.6. So I have -4.6 plus 5. 2.3 minus 2 is 0.3, a positive number though, right? -4.6 plus 5 is a positive number. It's actually 0.4. Don't worry about using a calculator here. You know that a positive divided by positive is a positive, right? Okay, so that's going to be positive right here. So any real number between those two numbers, -2.5 and -2, is going to make this inequality a positive number, but that's not going to be a solution because I need that to be negative or 0. So I'll put a little x there. And then finally we do the next one, 0. So same idea, think of this as the opposite of x. So the opposite of 0, which you know is 0, minus 2 divided by 2 times 0 plus 5. Well, the opposite of 0 is 0, right? So I get 0 minus 2 divided by 2 times 0 is 0, so it becomes 0 plus 5. 0 minus 2 is a -2. 0 plus 5 is 5, and we know that, obviously know that's negative. A negative divided by a positive is a negative number. So that means that any real number that's greater than -2 will make this rational expression a negative number, and that's something I want. So I'm going to go ahead and check this off. And then finally, the next thing we do is determine whether these two numbers we put in the number line originally will be open or closed circles. Well, first of all, notice that those two numbers came from that. Okay, so notice that this number, I should say, -2.5, is an undefined point. So automatically, that's going to be an open circle. -2 is a 0, and that's something I want because of that equal sign. So -2, when x is -2, it's a solution because that's going to make this rational expression 0. Make sure you see why. Let me just show you. So x equals -2, right? So let's make sure we understand why that's a solution. Make sure you understand why we're going to put a closed circle here. So if I substitute -2 into this original problem, into the rational expression, I get the opposite of the -2 minus 2 divided by 2 times negative 2 plus 5. Well, the opposite of negative 2 is a positive 2, so that's 2 minus 2. 2 times a negative 2 is a negative 4 plus 5. 2 minus 2 is 0. Negative 4 plus 5 is 1. 0 divided by 1, 0. So see, it makes it 0. I want it to equal 0 as well. All right? So that's why negative 2 is a solution, and that's why we must put a closed circle here, which when we do the interval notation, there's going to be bracket, there's going to be parentheses. And so the solutions are these two intervals. So we're going to go from negative infinity, remember parentheses always for negative infinity and infinity, to negative 2, I'm going to put 1/2. 2.5 parentheses union, and you could, since this is a terminating decimal, you can write it as negative 2.5 union, and then bracket negative 2 to infinity, and that's it. You found your solution. So the solutions are any real number that's in those intervals, and so that is the final lesson on solving rational inequalities of this form.